Greetings! Today I've got a Sky+HD box to take apart and to see what's inside of it, is it pretty on the inside, and see what can we salvage from it. It's a 3D Anytime Plus thing over here. The key is the plus thing and the little R button over here for recording, which means this has got a bonus hard drive inside, so definitely worth taking apart. I expect at least a 500 gig hard drive inside that after reformatting it's perfectly fine to use. Sky DRX 890Z model of the box, Sky part code 14465 if you're interested, and you can see the seal is still here, so yes, that's gonna be good to break that. Looking at the box on the outside, we've got a screw over here, a screw over here on this side. It's quite big, so mind you, I'm getting out of focus, out of camera view a little bit, and there's another screw right over here inside the hole, another one on the opposite side, and that should allow us to take the plastic off of it, I think. And the 4 screws are out. Time to cut the label. That's always good. And let's see if this will open. There is a little lever on those sides, and basically the side panel slides to the back and then it comes off. But they've got a fan as well, so this thing must be noisy. Why would people mount a fan in a set-top box? I mean, you're watching a movie, sometimes in the evening, you don't want it too quiet, not to wake up your kids and whatever, and you've got the box itself all of a sudden starts doing some weird update or something and blasts the fan at full speed. That is bad. Set-top boxes, audio equipment and all that sort of stuff should not have us fans in there, full stop. We can lift this flap over here and it appears that we can free the box from the plastic casing. I think I got it worked out. So the idea is you slide it backwards a little bit and then the other plastic lets go, and voila, we've got a box. We've got a large piece of plastic with all sorts of light pipes and lever pushes and whatnot, so we can put that to the side, and right now we have another box that needs to be taken apart. Okay, and there we go, that's the front panel. Over here we've got some tactile switches. If you're in a pinch, those are quite easy to desolder, because usually what they use is the two pin switches through hole instead of the usual 4-pin, which are really difficult to desolder without damaging the switch. Well, not that difficult, but more difficult. The 2-pin are super easy. Just heat it up and pull it out. And over here we've got some sort of micro-controlling, monitoring all the switches, receiving the infrared stuff, and controlling the LEDs and the ring of eye Sky thing logo. From what I see, we should be able to lift the front. You can see those pressed in pins. This is just a simple form of latch. There we go, it comes off and we are inside, and let's have a look at the construction. First of all, this one seems a little bit different from the ones I've taken apart before, because the power supply, the switch mode power supply section over here, which you can see the white line going across, this is the high voltage side on the inside over here. So yeah, if you take it apart, no poking over here because you might become a light bulb. But all of this is on a joint PCB with a smart card reader over here. Be careful when taking this stuff apart, because I'm not sure what I just touched, but all those metal cutouts are extremely sharp, and I've just made myself bleed. That's nothing unusual. Emergency first aid complete, electrical tape and some tissue. That's the job. It's on the same PCB, as I said, the power supply and the card reader, and what else? Well, the audio input, output and whatnot. Normally this the Sky power supply is just a straight long PCB, just the power supply alone, and then everything else is on a separate PCB, so that's different. And here is what appears to be the main PCB on the front of it, and we'll have a closer look at it in a moment. It's got the strange looking yellow silk screen, and we've got a massive nice heatsink. That's a very salvageable part. I've already undone one of the pin. No, I haven't. There we go, now it's undone. So we can take that pin. This is just a spring clip, and that's attached to the PCB with those little pin-like things. It looks like a pin header, but its arm goes all the way around, so it creates a little loop. And the heatsink itself, let's see if we can, it wiggles a bit. Ah, there we go. So yeah, this is very reusable. You can drill a hole in this and stick your power MOSFET or something onto this, and yeah, use it on something else. And here we've got some of that heatsink compound that it's one of those tape things when applied, so if we are gentle we should be able to take it off in one piece. No, that doesn't always work. Sometimes you have to resort to scraping it off, but it just makes a little bit more mess. There we go. Okay, we see a Broadcom chip. No surprise, as I said before, Broadcom has got this sort of industry on lockdown. Pretty much everyone puts a Broadcom chip over here that does all sorts of audio, video encoding, decoding, processing, and everything else. So in this case, it's a BCM 7335 QKF SBA1G. A mouthful as always, a BGA with lots of pins and a very long part number. Okay, I've unscrewed I think everything that was inside of this. So let's take it apart and then we'll look at all the boards individually. I'm going to take off those clips that are holding the cables together. That's nice, it's good practice to cable tie everything inside so it doesn't rattle and move around and whatnot. Detach the power from the power board, from the hard drive, and let's detach the serial SATA cable. That's out of the way. Let's try. There we go. That's the board, and here you can see a connector that looks somewhat like the hard drive connector, standard 0.1 inch header. That's it's a through hole, but it's a little bit unusual because it's not just a connector, you actually push the pins in from underneath. You can see the PCB has got all the holes needed in here. Interestingly, some of the holes are bigger than others. Not sure why, maybe... No, not sure why. The pins are all the same, but the holes in PCB, you can see the last 8 have got much larger cutouts. And on the bottom of the board is just a forest of the coupling caps all over the place, ton of them. So yeah, that to the side. Let's remove everything else. Okay, and this is how it's supposed to be done. We've got the tabs on the side over here, and those should unclip. And there are tabs at the bottom that should unclip as well. And then the bottom, the back of the unit comes off of the rest of it with all the nice print on there. And now this should come backwards easily. There we go. And that's the power supply board. Everything is okay. You can see a little dust accumulated over here. Usually the high frequency switch mode power supplies do that, they will attract dust, that's usual thing. But let's have a look at the main filter cap, which is here, and let's make sure there isn't anything left charging there. No, it doesn't seem so. Yeah, anything mains powered if it's got a filter cap. If you're taking something apart, first thing you do before you handle anything, discharge the cap. And if there was a spark on it, yeah, next time you handle it, after 5-10 minutes, discharge it again, because the cap can regain some capacity and still give you a jolt. And the hard drive, let's see. And ta-da! Pipeline HD 500 gigabytes. That's a win. Let's have a closer look at the boards. So we've got two PCBs over here. The main processing board and what it seems to be power supply and input-output for most of the connectors on the back, the analog ones it seems, and all the digital stuff plus high frequencies on the other board. And let's have a real close look at this, just because we can. And really quickly, starting from the input high voltage side, with yeah, there is those black things are just little inductors for noise suppression, a cutout for high voltage not to creep across, and some caps across it. And we've got another cap, fuse, the common mode choke that's a little bit out of focus. You can easily make a jewel teeth out of that. Here we've got a varistor, metal oxide varistor on clamping down the mains, and my lens fell off. And we've got a diode bridge, rectifier, some resistors that are red. I'm not sure what the color means. Here is the main filter cap that's again out of focus because it's too tall, but all the caps that I see on here are Rubicon, so good quality caps. This fat diode over here is definitely a big switching Schottky diode. And the controller chip, I've wiped the dust off of it. This is the TOP256PN, and it's a interesting chip. It's a switch mode controller, probably. I haven't checked it, I'm just deducing, but you can see it's unusual because it's got a leg missing, and the leg is missing not because they were trying to save some money on not putting one leg in. It's most likely because of the voltage. They needed the isolation between the pins over here, and yeah, that's how they've done it, just not put a leg in. Opto isolator going across to the low side, and that's all there is to it. Now on the front of the board we've got NXP TDA 8024T, and that's from what I remember, that's a smart card driver or transceiver, so it will communicate with your subscription card on here. Then we've got the standard Molex connector for the power, +5 and +12 volts and ground. 00 BCOW 1096, just without checking what I think this is. Most definitely it's a local voltage reg, and I can already see on the other end of the board there is another one like that. Those can easily be pulled out and reused. Here we have the tall pin header connector, some components that have not been fitted, and another chip which is not showing up very nicely. So instead of moving it around, I'm going to try to shine some light on it. There we go. PIC 16F726. So we've got a PIC microcontroller over here doing something. Not sure what, but there it is. Here we've got some unpopulated thing on the J9900, and that seems to be programming header for it. I think it might be. There is what appears to be a switch that's not fitted. Yeah, if you've got one of those boxes, try to short this out and see what happens, because this component over here should be a switch, and yeah, it should be doing something. I'm not sure what you're going to do. You might break your box, so be warned, but it will be interesting to find out what will it do. Maybe it's a reset, maybe it gets it into programming mode, I don't know. And further on what we have, this is the can which had all the RF input output things for the regular TV antenna type connectors, and we've got ASC374CAEF chip, which most definitely does all the stuff that it needs doing with the RF modulation, demodulation and all sort of stuff. 4 MHz crystal, and that's pretty much it. What's inside, a few surface mount components and a couple of coils just wound on a little ferrite former. And again, more caps, all Rubicon, a few transistors, and if I just turn it around because I'm running out of space, here is another one of those 00B cow voltage regs. And yeah, if you look it up, I'm sure I've reused those actually in the past. You can easily get a datasheet for them, and it's, as you can see around, it requires just a couple of components, and you can set it to different voltages from what I remember, and it's just a linear voltage reg. Nothing special, but just like LM317, same sort of thing. A few more pins because it's doing something extra, but yeah. And moving on to the more interesting board. This is the second PCB with the main processor, and let's begin from the RF input from the LNBs. and you can see this is the can. I had to cut off that piece of metal because it was right across the chip. So let me just move it a little bit forward and that will focus. There we go. And what we have, another Broadcom BCM3445, and that's basically interface for LNBs, custom chip dedicated for that, not custom to Sky, but just a dedicated dual LNB driver. And have a look at the PCB design over here. You can see at the top how basically those are mirrored, they're identical interfaces. We are dealing here with, you know, many gigahertz of frequency, and yeah, the design over here is absolutely critical. It has to be, it's getting out of focus again, but yeah, it has to be done in a certain way. It's, you know, the tracks over here, you can see it's very, very specific. It's always amazing when you look at sometimes when you look at the high frequency stuff, it seems like someone's done it just to make it look pretty, but actually no, it's got a real technical reason behind it. But nonetheless, it's really interesting. Let me just reposition this a little bit. There we go, that's better. So yeah, then we've got more passives, diodes and caps, big fat switching diodes on the sides. And yeah, that's all that's in this can. So we've got something that was meant to be marked but never was, and further down the board we've got the pin header connector, and yeah, from the top there isn't a difference, but at the bottom I'll show you again that there is some of them have got a bigger, much bigger cutout or hole in the PCB. Maybe that's for voltage. And here is the loop connector for the heatsink. Here is the C03A1C01, which basically is this. So it's a bunch of transformers, 4 transformers to work like in a configuration as a normal transformer, and 2 what looks like a common mode choke. And this chip, what it does, it provides high voltage isolation to comply with some international standards for local area networks. And yeah, it's an interesting device because yeah, very small, and 4 transformers inside. So yeah, that'd be interesting to reuse it for something else. And moving on to the left, we've got a device over here next to USB, this D6516, which is a dual high side switch, and it's used to protect the USB port over here because it monitors the currents, and yeah, it will, if it goes over a certain current, which presumably can be set somehow, this will basically shut off the USB. There is 2 switches in there which will disconnect if the current is exceeded. And moving on, here we have the spark gaps, nice little contained spark gaps, and all the circuitry required for the phone jack. This is most likely some sort of modem chip that does the phone jack communication. And here on the left, let's do some more shining light. ICL 3238, which, no surprise, intersil, and it's a transceiver for RS-232, so no wonder it's right next to the RS-232 connector that does all the talking through that socket. And what have we got here? We missed a chip. What is this? SI2457FS, which is a modem from Silicon Labs. So this is the modem. So let's go back to the other chip. What was that? That's interesting. So it's a DAA, which stands for Direct Access Arrangement, which basically it's designed for communicating through a telephone line, and it provides some isolation, and it's meant to be coupled with the 3056 that we looked at before. Those 2 are a set. And here we're moving on to memory from Samsung. Let's see how much memory this thing has. So we've got 1, 2, 2 and 3 pieces of memory chips. Now those two seem to be close together and one is a little bit further down. DDR2 SD-RAM, it's actually 1 gigabit in each chip, and those two chips, the ones that are separated by the Sky logo on the board, are both the same. So that's 1 gigabit of memory in each of them. And here we have a slightly different memory module, and this is a significantly smaller 512 megabits DDR2 SD-RAM. So we've got two 1 gigabit chips and one half a gigabit chip. We've got the actual Broadcom chip. You can see some scratches on here. That's gonna be interesting, so let's Google this. And this is what it is, BCM7335. It's a SoC, system on chip, which has got all sorts of ins and outs required for all the stuff that's happening. And we've got the BCM3445, which is the satellite input chip, which is right next to the LNB cable sockets. And yeah, those two work together, and we've got pretty much everything, entire set-top box. Moving away from this, there's one more possibly interesting chip. It's upside down, so I'm going to turn the board all the way around, and here we go, let's zoom in. It's a Spansion GL512P10 FFCR1, and that's a half a gigabit of flash memory to hold the program, software and everything else. And looking finally at the back of the board, there isn't much interesting over here. As you can see, it's just a ton of the coupling caps all over the place. That's a very common thing. A few resistors, but yeah, the back of the board is usually the place for all the coupling happening. And we've got yeah, the yellow silk screen, which is, it's not showing that well on the camera, but it's got a little bit of a weird tint to it. Here we have a Bodge manually added cap afterwards. Strangely, it appears as it is marked. There is provision to it, but it's the pick and place machine has not added it, and it was added on manually. You can see the soldering on it is completely off the standard compared to everything else. Yeah, those tiny packages are not ideal to solder by hand. As you can see, all the holes, that's where the 0.1 inch header from the power supply and the rest of the previous board come through. But towards the end we've got those 8 which have got significantly larger cutouts. I'm wondering why have they done it like this. Not too sure, to be honest, but let's see, because there is lines going through it straight over here, and it looks like those are somewhat controlled impedance. 0 ohm resistors put into, I think the only reason for those 0 ohm resistors was to jump over the track that has to go across, because clearly they haven't got any other function. And we've got those six pads over here, and that's where it seems to end. There are vias going across, so let's look on the other side of the board, and that's where the vias come through. And we've got the 585X devices. Those look like resistors, I think. Maybe, yeah, those are resistors marked as R, and that goes straight under the Broadcom. Okay, inconclusive, to be honest, because I'm looking back on the previous board, and yeah, 3 of those those are the 8 pins that go through the thicker holes. 2 of them seem to be grounded, 2 very bottom are unconnected, then 1 in the middle is not connected, and 3 snake out all the way through to the area where the SCART connector is. That's where they go to. Now the other ones are not connected on the bottom layer, the 3 that are not connected here, so it must be snaking off somewhere in the inner layers of the board, somewhere, wherever that is. Possibly all of them go to the SCART connector, so for some reason they've just had a larger hose for that. Right, let's try to get at this Broadcom chip with fire. So I've got my microjet eroder. Yeah, usually what's underneath those packages, you've got silicon that's kind of soldered onto the top layer, but if you heat it just enough, we should be able to pop it off, and if it pops off nicely, we'll be able to see the entire structure of the silicon. I need to wedge my knife in and apply some excessive heat. Okay, let's try. There we go. This is just for heat dissipation to aid this. So let's see if we can rub off that. Okay, a little bit of acetone. And there it is. No markings on it, just a piece of silicon. So let's see if we can work this out of the board. Screw it. Okay, there is the reminder of the SoC. You can see all the balls on there and what's left. That's how they mount this thing. It's amazing. You need multi-layer boards to get a chip like that connected to the board. Yeah, that's a little bit extreme over here, but what I've done. But I'm not bothered by it. I just wanted to see how many pins is under, how many balls, and there is a lot. For this video, I think that's going to be it. So sorry for a long one. I just wanted to go through some detail on here. I hope you enjoyed it. If you did, please do give me thumbs up, subscribe for more random stuff, and that's it for the time being. Take care.